My name is James Fair and I'm the Environment Editor of BBC Wildlife, the monthly natural history magazine. You can buy the magazine from all good newsagents and many supermarkets, and you can also find us at www.discoverwildlife.com or tweet us at wildlifemag. And just before we get going, here's a short advert.
My name's Rachel Jelly and I work for Sunville Holidays, and I'm going to talk to you about finding the real pharaohs. Let's start with the birds. The Faroe Islands has 2 million pairs of birds with over 300 different species. Guillemot, snipes, oystercatcher, puffin, the gannets and the petrels. It really is a nature lover's dream. Visit sunville.co.uk or call 0208 758 4722.
Today, we've got a real treat for you because just before Christmas, I spoke to Brian Cox about his new 5-part TV series, The Wonders of Life, which is being shown on BBC Two on Sunday nights. It is the third part of a trilogy consisting of The Wonders of the Solar System and The Wonders of the Universe, which were broadcast in 2010 and 2011. And in this new series, Brian looks at the evolution of life on Earth from a physicist's perspective. Essentially, how have the forces governing our world influenced the way in which life has developed? This new series will take the viewer from diving with octopuses off Florida Keys to exploring the thin line between the living and the dead in the volcanic region of Southeast Asia, from explaining how the forces of gravity and electromagnetism have affected the way that different organisms have evolved, to asking whether environmental conditions on other planets have also allowed life forms to flourish elsewhere. With this in mind, I started by asking Brian how the story of life on Earth as told by a physicist differed to that told by a zoologist.
I think I should say that the motivation for the series was that for many years I read a book many years ago called What is Life by Erwin Schrödinger, which is a very famous book. It was written in 1943, based in lectures he gave in 1943 in Dublin, called What is Life, and he addressed 2 central questions in that book. And Schrödinger, of course, is more famous for quantum theory than for being a biologist. He's a great quantum theorist, father of quantum mechanics in many ways. But he asked the question, how is information passed from one generation to the next? Because this is 10 years before the discovery of DNA. Well, he predicted there must be, he called it an aperiodic crystal, but there must be some molecule that's capable of passing on information from generation to generation. And actually you see Watson and Crick cite that book and those lectures as part of the motivation to go and look for DNA. And secondly, a really deep question, which is really the subject of the second programme in the series, which is life appears to violate one of the fundamental laws of physics, called the second law of thermodynamics, which says that the universe tends to become more disordered. And life is absolutely the opposite. Life is the spontaneous emergence of order. We are human beings are the most ordered structures we know of in the universe. So the question is, how do ordered structures, so ordered, a biosphere, how does that emerge spontaneously given the known laws of physics? And he goes some way to answering that, but actually now we know that there's a whole subject called non-equilibrium thermodynamics. I push very strongly for the programme to be called that, but they wouldn't let me. Wonders of non-equilibrium thermodynamics. I think that's a more accurate description. So So in that sense, it's asking those questions. But we're using animals and using some of the techniques of natural history filming, but to ask questions like, how is this thing consistent with the laws of physics? What are the laws of physics that constrain the form and function of animals? Why are the biggest animals on Earth in the oceans? Why are small animals completely different in form to big animals? And you find that it is basic physical laws. It's the constraints placed on living things by the laws of physics that constrain evolution, as of course they have to. So that evolution doesn't have a free hand. It has to produce things, obviously, that are consistent with the basic laws of physics.
I think that's really interesting, and there was something I picked up on in that first programme where you're discussing how our senses rely on electricity to work, and at one point you say nature abhors an imbalance, I believe. Yeah. And what I was interested there is when you use the word nature there, you're basically talking about the laws of physics, aren't you?
Yeah.
Whereas when our writers use the word nature, they mean living things. I mean, I was wondering whether you were conscious that you were using this word in a different way to other people, particularly say other presenters of natural history programmes. And I also wonder if in some ways the distinction I've made there is artificial in any case.
Yeah, it's a good question, that. A series of good questions. So physicists talk like that. I mean, when a physicist talks about nature, you're talking about the laws of the fundamental laws that govern the universe, the laws of physics. And so physicists will use them interchangeably. So that's the reason for the different language. So it's not conscious, it's just the way that physicists talk. But I think now, there was another question there.
I wonder whether, I'm drawing a distinction between the way you use nature and the way our writers and other natural history presenters would use the word nature. But I also wonder whether, and you sort of touched on this in your first answer, whether in fact the distinction between the sort of nature as in laws of physics and nature as in the way in which sort of living things, maybe that's an artificial distinction because
I remember,
one is related to the
you
other.
said nature abhors a gradient. No, I said that.
Or nature abhors a vacuum.
That's interesting because, sorry, it keeps fading in and out a bit actually. But anyway, so the probably the best, in my view anyway, in our advisor's view. I should say I work with very closely with Nick Lane at UCL, who wrote a great book called Life Ascending, and also a professor at Manchester called Matthew Cobb, who's a professor of zoology. The one of the best explanations for the origin of life, and the one that is, I think, most favoured now, is that it began in the presence of gradients, in particular, and we do this in the second programme, in particular pH gradients. So 3.8 billion years ago on the primordial Earth, you have vents in the deep oceans which were alkaline, and they were in an acid ocean, so the oceans were acid at the time. And what you find in the field of physics, which has got this name called non-equilibrium thermodynamics, you find that it seems that ordered structures can emerge spontaneously in the presence of gradients. And their function, from a physicist's perspective, is to equalize the gradient faster. So in that context, what you find is that if you've got pH gradients, temperature gradients, even electrical gradients, you tend to get complex chemistry, complex carbon chemistry emerging spontaneously. And this may be the answer to the origin of life. It's a thermodynamic imperative. If you give it probably liquid water, gradients, and then some basic carbon compounds in contact with rock, then you will get the emergence of chemistry which is very similar to the chemistry of life. So it's very important, actually, this idea, which is expanded on a lot in the second programme, actually. And because the question is that living things, as I said, they appear to run counter to the laws of physics. Of course they don't, because they can't. But it feels different as a living thing. You look at life, and you alluded to this in the language, the question about the language. It feels that it's different to nature as a biosphere feels different to nature as a star or a galaxy. And as you sort of intimated, it's an artificial distinction. There is no difference between a living thing and the dead thing, really, right? So when we ask the question in the second programme, what is the difference? Because I suppose there is a difference in the sense something can be alive or dead. But actually, the biosphere as a whole is a database, a continuous database that has been changing and evolving and growing since the emergence of life on Earth, since the last universal common ancestor, which people call Luca. So the question is, although individuals live and die because the processes that power them stop, the information content is a continuum. And, we do we touch on these ideas that Richard Dawkins writes very well about it. It's about the idea of species, of dividing life up into boxes and saying here is one species and here is another. Completely artificial construct, which is one of the things that leads to confusion when people start talking about missing links. What's the missing link between, primates and humans? Well, it's nonsensical. It's a construct that zoologists and biologists knowingly place on life in order to classify it. But actually, you're to see the biosphere really as a whole, constantly shifting and changing information database in a sense. So maybe that's too complicated an answer, but it's we address a lot of this actually in the second program, and then the fifth program, which is specifically really about speciation. The fifth program is the most classically biological program, mainly filmed on Madagascar, because Madagascar is a beautiful example of an island, and islands are important in speciation, both physically and metaphorically.
I was interested there. I just wanted to pick up on one thing, and basically you said that the purpose of life is to. You didn't quite say this, but this kind of summarising is to equalise gradients.
Yeah.
So that kind of puts us in our place, doesn't it?
The classic example in physics is storm systems. So you have high and low pressure areas in the atmosphere. You get tornadoes in certain circumstances appearing, which are what we'd call low entropy systems. They're ordered systems. They're a spinning column of air that has a structure. And there's a really quite modern way of looking at that the ordered systems emerge in order to equalize gradients. Right. So that's a very modern physical way of looking at complex systems. So it's well known in physics, you get complex systems emerging spontaneously. Well, that's beginning to be carried over now into biology. It's very fashionable at the moment, actually, as a research area. So the question is, do you get complex carbon chemistry emerging spontaneously in the presence of gradients? And the answer is probably yes, which is probably the answer, or the beginnings of the answer to the origin of life, to that question, how did life emerge? Probably because it's inevitable.
I think I was going to ask this towards the end, but you touched on it a couple of times there, and you particularly the final program, which I haven't seen, in Why Life on Earth is So Fecund, and you say it's down in part to carbon as the universal building block, and I think you also promise to look at whether the conditions for life may be repeated elsewhere in the universe. I just wonder whether do you look in the program, and do you have an idea yourself on what other life forms away from the Earth may be like, and will they be built out of possibly different elements? I know silicon has been posited as a possible building block. What do you think? Do you have a sort of a particular view on this?
Well, first of all, we don't actually address that in the series. We leave it as an open question, and the reason is that we're going to film another 2 programs, which the BBC the press department may be panicking or not as I announce this. But anyway, we are filming another 2 programs, which is loosely called Aliens. So actually, it was so interesting that we've actually hived it off into another couple of programs we're going to film next year. So we stop with the suggestion, because what we've done through the series is we've developed, I think, an argument, a thread through the series, which is saying that simple life, as I think the best scientific view is that simple life is inevitable given the right conditions. However, complex life is a different question altogether. So the best example is the emergence of the eukaryotic cell, which is, so the cells in our body are eukaryotes. They have a cell nucleus, very complex, whereas things like bacteria are prokaryotes, which are simple cells. That happened once on Earth. It's one of the few things that biologists will say with any certainty. I've learned about biology that it's a science of caveats in a way because it's so complex. This seems to be true. But what happened was that 2 single cells merged together on Earth over 1 billion years after life began and didn't kill each other. It's probable that one of them was an archaea and one of them was a bacteria. So 2 of the kingdoms of life, the single-celled kingdoms, merged together to form this chimera. It's called endosymbiosis. And that seemed to happen once, as far as we can tell.
So that's life on Earth, but what about life elsewhere, I wondered?
So these appear to be quite rare events, that when life forms merge together, but you need that to form complex life. So who knows about complex life? We've only got one example, but simple life, I reckon, if I had to guess, I'd say we'd find it on Mars, or at least signs that there was life on Mars, because we know there's water on Mars, and we know there was once a lot of water, and I wouldn't be surprised if you found it in the oceans of Europa either, for that matter.
Europa being?
The moon of Jupiter, which has got an enormous subsurface ocean, more water in Europa than there is in the oceans of the Earth combined. And it's a saltwater ocean below an icy surface. And, what we find on Earth is, anyway, we do this in the fourth program, actually, we address this to some extent. Water seems to be very special. Perhaps as special, well, actually not perhaps, I would say as important as carbon. So there's a minimal set of things you need for the chemistry of life. Water is one, and carbon is another one. Silicon probably doesn't, it's not chemically as powerful as carbon in forming long-chain molecules. Because although it's got 4 electrons, so you can bond in the same way, because of its inner shell of electrons, then it's not as voracious in its appetite to bond. So probably carbon is the only way you can do it. And water is the framework within which biology happens.
Moving on a bit, I wanted to ask you about how would you describe your relationship with nature, and by that I mean living things. I mean, are you an outdoorsy sort of person? If you go for a walk, are you looking for birds, or are you, I don't know, wondering about the forces that hold the material world together?
No, this actually, it's kind of interesting. It's changed as a result of making the series, actually, and that's one of the reasons. Going all the way back to Wonders of the Solar System, actually, one of the things that I think the production team have always thought is that we want to change the way people look at the world. Right? So with astronomy, we want to change people's relationship with the sky. You can there's a very famous quote by Carl Sagan where he said when he was growing up, he said, "What are the stars?" And someone said to him, "They're lights in the sky, kid." And he thought there must be more to it than that. And then he found out that they were other suns, right? And that transformed his life, because then he was looking at these things in the sky, thinking these are other worlds, right? That one piece of information changes your relationship. And in a sense, I think since I last did biology back in the 1980s at O-level, the subject has transformed. Our understanding of it is completely transformed with techniques like cheap sequencing of genomes. And we understand the tree of life so much better now than we did then. And once you see that, once you start to know about the processes that are occurring and the relationship between different species, and just Darwin's theory of evolution by natural selection, obviously I knew about that theory, but I've never really understood it properly, understood the depth of that insight. And once you do, then I think you do absolutely look at the world in a different way. And actually in the last program, I kind of summarised, it was the scene we filmed last. It's very rare, actually. Usually in these programs you make them all out of order. But we filmed episode 5 last, and the last scene was on the last day of filming. And I said what I'd learnt, really. And what I learnt was that if you look at a piece of grass in the crack in the pavement on the road outside your house, right, it's unremarkable in a sense, but actually it is unique, right? It is an absolutely unique piece of the universe. The steps that went into the production of that thing are so unlikely. Now that's not to say that life is unlikely, it's just that particular thing, that particular species, that particular biochemical way of proceeding, so unlikely that it makes it uniquely valuable. And it's very important, I think, actually. You start looking at a biosphere, and no matter how inevitable life is in the universe, there is no inevitability about a tree. Right? There won't be trees like that anywhere else. And I think that was I really realised that. And really when you truly understand what the content of Darwin's theory is and what the content of the biochemistry is. And these steps, like the emergence of the eukaryotic cell, the emergence of oxygenic photosynthesis, that happened once. We know that happened once because all plants do it in the same way. And that you begin to think, well, this is a valuable thing we're looking at here. It's undoubtedly unique in the universe.
After a few technical hitches, I was able to ask Brian about some of his favourite filming moments of the series. Which animals had he most enjoyed meeting, I wondered?
The eye was tremendous because we went out with because they're endangered, obviously there's a team there from an American university that's putting GPS collars on them so they can map, because it was thought to be extinct about 10 or 15 years ago. Now they thought that there are around, well, there's certainly less than 10,000 individuals, and so they're tracking them. So they have to tranquilize them occasionally to go and get their collar back and put a new battery on the collar, so they're running this research program. So we managed to hook up with the team that was putting the collar on a mother and a child. And so they basically tranquilize them, get them down for the day, because they're nocturnal animals, change the collar, and then re-release them. So we got to see that, and so I got to hold this quite groggy eye and talk about it. As an example, actually, it's the explanation in the film of Darwin's theory, essentially. It's going through the fact it's got this bizarre finger and all the things, its adaptations to be a woodpecker, essentially, which is the niche thing. So that was a wonderful experience. But actually, the one that was most strange and affecting for me was we did a lot of underwater filming, which was a new thing for me. And we filmed an octopus in the wild program out there in the ocean. Yeah. Oh, you saw that one, actually.
Yeah. You filmed the common octopus off Florida Keys or somewhere, isn't it?
In Florida, just off the Florida Keys, actually, next to a flyover. Very bizarre. But that was wonderful because as an alien intelligence, I said in the programs, I don't need to tell you, I suppose, but as an alien intelligence, it's about as far separated from us in evolutionary terms as you can get as an intelligent animal. And yet, you see, there's a commonality, there's some kind of interaction you have with it that you understand. You understand it as an intelligent thing, even though you've got to go back 600 million years to see a common ancestor between us and an octopus. There were no brains or eyes or anything at the time that you'd recognize as intelligent. So it's an intelligence that evolved separately. And I found that quite powerful, actually, because it was, you think if we were to meet aliens that were intelligent, you would imagine there would be a commonality, because there's a commonality and a relationship you have with this animal that is not to do with our common ancestry. So I found that quite interesting.
In the program, it almost appears, I can't remember what you're saying, but it almost looks like it's sort of holding its sort of fists up to you, doesn't it?
Boxing and mimicking, which they do. So they're well known for doing that.
Oh, are they? I didn't know that. I know they can do all sorts of stuff with themselves and turn themselves into all sorts of weird shapes and so on. But so that was a particular highlight of making the program, the octopus.
I think it certainly was. As I said, the eye was another one. We did some work with great white sharks, which was a real privilege to dive with those.
Had you dived before? Is that new?
Yeah, not much actually. I'd learned to dive actually with the BBC for Wonders of the Solar System, and we never used it in the end. We didn't really do anything. But it was technically more complicated because we had this face mask which has been used, I think, on many natural history programs, but in technical terms it's rather difficult. But of course you can talk, so that was very enjoyable. So I think the underwater stuff was new to me anyway, and I enjoyed that a lot. And
just to wrap this up, really, because I know it's 11:30, and I think we've covered quite a lot. So the next thing will be aliens then.
Yeah.
Yeah. And are you going to look at the sort of possibilities of intelligence?
Yeah. To be honest, it's in development now. The idea that was we were going to film the last episode of Wonders of Life about alien life, and we didn't because it just seemed wrong in the end. We wanted a program specifically on Darwin. It's called the last episode is called "Endless Forms Most Beautiful," and it just felt like we should do that. And so we just decided that we'd do the alien life thing. We'd launch off into it at the end of that program, which is what we do. So we'll pick it up for 2 specials, I think, 2 1 hour.
And can you just sort of say a little bit of, not necessarily speculating on the forms that intelligent life might take, but the possibilities of intelligent life out there? How do you assess that?
Well, I think it seems to me the consensus now amongst many biologists, it is a consensus, is that if you have the right conditions, you would expect simple life. I think, that may be slightly too strong, but that's a consensus, I think. And that's why we're on Mars looking for it, because we think it's probably there. So, simple life, yes. Very surprised if it isn't all over the place. Anywhere there's liquid water, I would say, and some kind of stability. So you don't want liquid water to be there for 100,000 years. You need it to have been there for millions of years in a stable environment. Complex life, though, what I learned in this series is that as I mentioned, there are a sequence of things that happened on Earth which we have no idea about the probability of, other than it looks like, because they've only happened once and it took a long time for them to happen, you could infer that they're rare. Now, that's not very scientific. You've got to be careful because we've got a sample size of 1. So I think intelligence is a big question. There's the Fermi paradox, very famous paradox in physics, in science, pointed out by Enrico Fermi, is that because there's been so much time, our galaxy has been around for over 11 billion years. There are 400 billion stars in it. Lots of planets that we're discovering now, over 2,000 I think we've discovered to date around different stars. You would expect there to be civilizations that are more advanced than us, and therefore you would expect to see them, because there's one thing intelligence does, it makes itself visible. It's very easy to see intelligent civilizations, and we haven't seen any. So that you may think that suggests that the emergence of intelligence or civilizations is rare. And it could be there's a block. It could be that the emergence of complex cells is very unlikely.
I have to say I'm looking forward to what Brian has to say about alien life, but we'll have to wait a while longer for that. Somehow I doubt there will be that much about little green men or spinning saucer-shaped UFOs. And just before we close, here's another short advert.
The Faroe Islands are ideal for hikers, for photographers, for artists, as well as the bird watchers themselves. Perfect for walking, great scenery, easy to travel around, easy to explore by car, by helicopter and by boat, and great bird watching experiences. Visit sunville.co.uk or call 0208 758 4722.
You've been listening to the podcast from BBC Wildlife magazine. If you downloaded this podcast via iTunes, don't forget that you can also access it via our website, www.discoverwildlife.com. My name is James Fair, I'm the Environment Editor, and thanks for listening.